But now we just have to, see, this piece right here, I always have to stop and think really hard about, let's see, do I need it bigger or do I need it smaller? And then if it didn't work out, I'm annoyed with myself, like this early one over here. But this is exactly what I do. I have to say, okay, what's happening to the denominator, what's happening to the numerator. So this one, I'm always fiddling around to try to make the inequalities go the right way. This one, all we have to do is set up a limit. And you know I love L'Hopital's rule. So here's what happens. We've got two positive term series, and we take the limit as n approaches infinity of a sub n over b sub n. If that equals some number L, where L is finite and positive, then both converge.
If you don't get a finite or a positive number, then
it's an interesting question. Will this always work? I'm guessing that there must be some series that when I compare to it, it turns out to be an infinite amount, but you know what? I don't have an example of that. But I'd be so surprised if they stated a theorem with that added condition if it always held true no matter what. So there must be some place where this turns out to be an infinite limit, and then you can't conclude. You'd have to go back and try some other test. So look how nice this is. I think maybe you're asking, should we try the nth term test for divergence? Is that what you were suggesting? No?
I was saying divide by the lowest power of n so that it's cleaned up better.
It's, I don't know that that'll clean it up any better. Now you're going to get 1/2 minus 4. You'll get n to the negative 3/2 over 1 plus n to the negative 2. I don't think that's a nice idea. But we do take a piece of that thinking. What we're going to do is try to compare to, take the highest power in the top and the highest power in the bottom. So that's 1 over n to the 4/2 minus 1/2.
What are you doing?
3/2. And that's a okay. To be a geometric. Okay, it's a p series, and the p is
greater than 1.
so it
Diverge. No, converges.
p is greater than 1. I think it converges.
Yeah, converges. It's
Okay.
confusing
So
because
this
usually when
is
it's
a
smaller,
p series, and it converges.
so it's greater than 1. So it converges.
Okay. So I'll now take my limit as n goes to infinity of this square root of n over n squared plus 1 over 1 over n to the 3/2. Oh, no, easier than that. Let's clean it up. This is a fraction divided by a fraction, so we can invert and multiply.
I guess that works.
What are we dividing?
That's the rule.
Because
Oh, yeah, the new rule.
over,
Never mind.
yeah, we're trying to do an example of the limit comparison
Yeah.
On a problem
test.
like this, why don't we first try the nth term test before we go on to doing something as complicated as this?
You bet. That's a perfectly valid question. His question is, I don't want to do all of this work. What if I try the nth term test?
It's not gonna work, but I mean, this one.
Yeah, I know, it doesn't work. Nth term test for divergence. So I would just quickly take the limit as n approaches infinity of n to the 1/2 over n squared plus 1. And now, that's what I thought Brody was going for earlier. You would divide through by, well, you could do either thing. You can do L'Hopital's rule, or you can do Calc 1 and divide by the highest power. So I don't care. What would you? Would you do L'Hopital's? Okay, if we did a L'Hopital's, legitimate because the top is going to, and the bottom is going to infinity. So by L'Hopital's rule, I've got the limit as n approaches infinity, 1/2 n to the negative 1/2, 2n on the bottom. So that's the limit as n approaches infinity of a 1 over, let's see if I make this right, 1/4 n to the 3/2. Hope that's correct.
Yeah.
Somebody better check my arithmetic.
That's right, 1/2 times plus.
I don't believe you. Invert and multiply. Yeah, okay, I believe myself now. And now when I take the limit as n goes to infinity, it equals 0. And the test fails. The nth term test says that it can't equal 0. So now you did all that work and you still don't have an answer. But I always try this test first, to tell you the honest truth. I always try this first in hopes that I can be done with the problem. But the directions in the homework are pretty specific. It says, use the limit comparison test to determine the convergence or the divergence.
So even if it worked,
So even if it worked, you couldn't get away with just that. Okay, so now what happened over here? We got a limit as n approaches infinity, n squared plus 1. Top's going to infinity, the bottom's going to. So L'Hopital's or Old Calc 1. If you do L'Hopital's,
If your first term goes to the same power, can't you just get the ratio?
You should divide everything by n squared.
yeah, I probably would have done Old Calc 1 on it, because this one's kind of nice. Okay, and since we just did a L'Hopital's over there, let's go to a Calc 1 solution. There you divided each term by the highest power found in the denominator. So it looks like n squared over n squared over n squared over n squared plus 1 over n squared.
So 1 over n squared.
1 over
1 over.
So it's just your 1.
Yeah.
1
1
plus
plus
1 over n squared. But 1 over n squared is going to go to
Infinity is
0.
So it's 1 over 1.
1 over 1 is 1.
If you have